In this video on section 2.5 outcome 3, we're looking at solving equations with rational exponents. One thing that you need to look at when you're solving equations with rational exponents is the idea that if you have a rational exponent of m over n and it's equal to something, in order to cancel out the rational exponent and get rid of it, what you do is you raise it to the inverse power. So if your power was m over n, you multiply it by the inverse, n over m. And whatever you do to one side, you also want to do to the other side. And this cancels out the rational power on one of the sides. Now, if m is even, your answer has to be either a positive or a negative. If m, which is the numerator of the rational exponent, if m is an odd number, then you just leave your answer as k and power of n over m. And I'll show you how that works out, looking at whether m is even or m is odd. Let's look at our first example. In our first example, we have 3x to the power of 3/4 minus 6 equals 0. The first thing that we're going to do is we're going to bring the 6 over to the other side and isolate our rational exponent. So I'm going to add 6 to both sides. That's going to give me 3x to the power of 3/4 is equal to 6. And then I'm going to get rid of the 3. And again, this just isolates my x term. And that's going to be equal to 2. Now my next step is to cancel out my rational exponent of 3 over 4. Now looking at this, my m value is odd. So that means I don't have to do the plus or minus. And to cancel this out, what I want to do is take x to the power of 3/4 and raise it to the inverse power of 4 over 3. What that does is it cancels out my, my rational exponent, but I also have to raise my 2 to the power of 4 over 3. This leaves me with x on one side and 2 to the power of 4 over 3. My next step is to simplify, to get my pointer here, is to simplify 2 to the power of 4/3. We don't like to keep our exponent as a fraction. So remember that whenever you have a to the power of m over n, that's the same as taking the n root of the term to the power of m. So that means that 2 to the power of 4/3 becomes the cubed root of 2 to the power of 4. And 2 to the power of 4 is 16 cubed root, and that's approximately equal to 2.52 if you were to put that into your calculator. So that's what x is equal to. Now if I wanted to perform a check on this, I would go back to 3 x to the power of 3/4, but for x I would substitute in my 2 to the power of 4/3 all to the power of 3/4 minus 6 is equal to 0. And now I'm going to simplify this section in here. 2 to the power of 4/3 raised to the power of 3/4 is the same as multiplying 4 times 3 and 3 times 4. So that gives me 2 to the power of 12 over 12 times 3 minus 6 equals 0. And of course 12 over 12 is 1, so that's the same as saying 3 times 2 minus 6 is equal to 0. And 3 times 2, of course, is 6, minus 6 equals 0, so this is true. So x does equal, all of these I should say, but x does equal 2 to the power of 4/3, which is around 2.52 because my check does work out. Let's look at another example. Okay, in this example we have x to the power of 2/3 minus 3/4 equals negative 1/2. So the first thing that we want to do in this one is we're going to isolate x to the power of 2/3 by adding 3/4 to both sides. So x to the power of 2/3 is equal to negative 1/2 plus 3 over 4. I want to simplify this side, so I want to make equivalent fractions. So my negative 1/2, I want to have the same denominator on the bottom. So this will be negative 2 over 4 is the same as saying negative 1/2 plus 3/4. And then I can easily add these together. So negative 2 plus 3 is going to give me 1/4. So negative 2/4 plus 3/4 is equal to 1/4, which is equal to x over 2/3. So once I've got that simplified, my next step is to cancel out my rational fraction, or my rational exponent. And to do that, I'm going to do my inverse for my exponent. And I'm also going to do that to the fraction as well. So 1/4 to the power of 3 over 2. That leaves me with x on the left-hand side and 1/4 3 to the power of 3 over 2. However, because my m is even, my m value, which is right here, m is even, I have to put plus or minus 1/4 to the power of 3 over 2. And then that's going to be equal to the following. So x is equal to plus or minus 1/4 to the power of 3 over 2. I'm going to simplify 1/4 to the power of 3 over 2. That's going to be 1/4 cubed, all under the radical sign. So the square root of 1/4 cubed. To simplify this, 1/4 cubed is equal to 1, oops, let me grab my pen here, 1 over 16, all square root, and the square root of 1/16 is 1/8. So x is therefore equal to plus minus 1/8. And of course the key to this question is to realize that m is even, and therefore we had to include the plus minus in our answer in our solution. So in this case x is equal to plus or minus 1/8. Okay, let's look at another example. This is checkpoint 5 in our textbook, and the equation that we're solving x for is 5x to the power of 3 over 2 minus 25 equals 0. Right away, we want to identify that m in this case is an odd number. So we don't have to worry about plus or minuses in our answer. Our next step is to move negative 25 over to the right side because we want to get x by itself. So we'll have 0 plus 25 gives us 25, and then we're going to divide both sides by 5, and that's going to isolate x to the power of 3 over 2 is equal to 5. Our next step is to cancel out our rational exponent, and to do that we're going to raise it to a power that's the inverse of that exponent. So if our exponent was 3 over 2, we raise it to the power of 2 over 3, and we must also do that to the other side of the equation as well. Those cancel out, leaving us with x, and x is equal to 5 to the power of 2/3, and it's going to stay positive because our m was odd, therefore we don't have to include a positive and a negative sign. Now we're going to simplify 5 to the power of 2/3, and that's going to give us the cubed root of 5 squared, which is going to be the cubed root of 25, which is approximately 2.9. So x in this answer is going to be equal to approximately 2.9, or the cubed root of 25. Okay, let's look at one more example. We're looking at x to the power of 2/3 minus 8 is equal to -4. This is question B in checkpoint number 5 in the textbook. So again, the first thing that we want to do is we want to isolate x to the power of 2/3 by bringing -8 over. That's the same as adding by 8. So x to the power of 2/3 is equal to -4 plus 8, which gives us +4. Then what we want to do is we want to cancel out the rational exponent, and we do the inverse exponent to do that. And we also have to apply that to both sides. That's going to leave us with x by itself on that side and 4 power of 3 over 2. We now have to simplify 4 to the power of 3 over 2. That's going to give us the square root of 4 cubed. X is going to be equal to that. And 4 cubed is the square root of 64. Now in this case, looking at our numerator for our rational exponent, our m in this case is going to be even. So that means to our answer we have to add the positive and the negative sign. So to finish off this question, here we go. X is going to be equal to positive the square root of 64, which is going to be 8, and negative the square root of 64, which will be 8. So x is going to be equal to +8 and -8. So our solution is -8, +8. And that's it. I hope you find these examples helpful for this section, and thank you for watching.